Welcome to this explainer. Today, we're diving into the hidden, and honestly kind of fascinating, business structures that actually power the waste management industry. We're going to use the SASB sustainability standards as our decoder ring, so to speak, to uncover exactly how this massive sector operates behind the scenes.
So let's just jump right in. It's incredibly easy to think of garbage as a single monolithic problem, right? You haul the bin to the curb, a truck rumbles by to take it away, and boom, it's out of sight, out of mind. But let's stop and ask ourselves, when you throw something away, what kind of business actually catches it? Because as we'll see, the companies on the receiving end operate under totally different business models, and they face wildly different risks and opportunities.
Here's how we're going to break this down today. First, we'll look at the waste industry divide. Second, we'll examine the vertically integrated giants. Third, we'll pivot to the specialized niche players. Fourth, we'll explore their shared labor and safety risks. And finally, number 5, we'll look at the resource recovery future.
All right, Section 1, the waste industry divide. What's really interesting here is how the entire industry is essentially split right down the middle. On one side, you have these vertically integrated behemoths. These are companies doing absolutely everything, from the second your curbside pickup happens through the transfer stations, all the way to final landfilling and recycling. They own the whole process. On the other side, though, we have incredibly sharp specialized entities. These guys focus purely on highly technical niches. We're talking treating hazardous medical and industrial waste, operating really complex waste-to-energy facilities, or providing advanced environmental engineering consulting to massive industrial clients.
To get an unbiased look under the hood at how these different businesses operate, we're relying on specific financial reporting and sustainability metrics. The SASB framework gives us a standardized lens, looking at things like greenhouse gas emissions, fleet fuel management, and air quality, so we can see exactly how these different structures measure their environmental and operational impacts.
Moving right along to Section 2, vertically integrated waste giants.
Because they manage both the collection and the transfer of waste, these integrated giants operate massive vehicle fleets. And this brilliantly illustrates their first major challenge: fuel. These companies are strictly required to track their total fleet fuel consumption measured in gigajoules. But, it's not just about how much they burn, they also have to track their percentage shifts toward natural gas and renewable fuels. Upgrading to a natural gas or fuel-efficient fleet is a staggering capital expenditure, for sure, but it mitigates regulatory exposure and actually makes them way more competitive for new municipal contracts, especially in communities that are highly sensitive to heavy traffic and local air pollution.
On top of that, these vertically integrated models generally own vast landfills, and man, that brings significant regulatory risk. Landfills generate massive amounts of methane just from the anaerobic decomposition of all that waste. This represents a huge chunk of their Scope 1 direct greenhouse gas emissions, which are measured in metric tons of carbon dioxide equivalent. So to manage this risk, these integrated companies have to invest heavily in gas collection efficiency. They literally have to capture this gas and then either flare it off to reduce its toxicity, or, even better, convert it to energy to power their own operations or sell it off as natural gas.
That brings us to Section 3, specialized niche waste players.
Let's consider a waste-to-energy operation for a moment. This is the conversion of non-recyclable waste materials into usable heat, electricity, or fuel. And they achieve this through intense, highly technical processes, things like combustion, gasification, and anaerobic digestion. So this isn't just digging a hole and covering it up with dirt. This is highly specialized industrial processing.
The crucial point here is the fascinating environmental trade-off these specific facilities face. By incinerating waste, waste-to-energy operators actually create higher short-term Scope 1 emissions directly from their own smokestacks. However, they are simultaneously decreasing future long-term life cycle emissions by diverting that exact same waste away from landfills where it would have just sat there slowly leaking methane for decades. Plus, they're displacing the need for fossil fuel energy generation somewhere else on the grid. So it's a really complex balancing act of short-term emissions versus long-term life cycle benefits.
Meanwhile, specialized medical or industrial waste entities are intensely focused on a completely different metric: hazardous materials. They meticulously track what's called their toxic release inventory, or TRI, in metric tons. A massive priority for them is monitoring the exact percentage of this toxic inventory that gets released to water. Because, think about it, poor management here can contaminate soil and groundwater, leading to catastrophic regulatory penalties and lawsuits. Because of this, they are constantly implementing corrective actions, like drilling groundwater monitoring wells to catch and clean up any potential landfill releases before they escalate into a disaster.
On to Section 4, Shared Labor and Safety Risks.
So, despite their differences, both business models rely heavily on organized labor. Because the work is grueling, collective bargaining agreements are incredibly common across the board. Companies must carefully track the percentage of their active workforce under these agreements. If labor relations are managed poorly, waste management entities are highly vulnerable to strikes. They have to report the number of work stoppages involving 1,000 or more workers and track total days idle. Extended strikes can completely stall operations, which creates massive reputational and financial risks, regardless of whether you're a giant or a niche player.
And because of the inherent, literal dangers of this job, workforce health and safety is a paramount financial reporting metric. The waste industry naturally has higher fatality rates than most other sectors, driven by transportation accidents, contact with heavy equipment, and exposure to harmful substances. It's also worth noting that they have to track these incident rates not just for their direct employees, but for contract employees as well, meaning they absolutely cannot just outsource their safety responsibilities and wash their hands of it.
Now, when these companies calculate their safety metrics, we're talking total recordable incident rate, fatality rates, near-miss frequency rates. They rigorously calculate them against a very specific standard baseline number, 200,000. Why 200,000? Well, it's pretty simple math. That number represents the total hours that 100 full-time workers working 40 hours a week for 50 weeks a year would provide. It standardizes the data completely. This allows investors to fairly, apples to apples, compare the safety culture of a massive integrated giant against the much smaller specialized operator.
Finally, Section 5, the resource recovery future. Driven by strict new regulations, changing consumer demands, and the absolutely skyrocketing costs of virgin materials, the entire industry is shifting away from mere disposal. We are moving toward resource recovery. Companies are now meticulously tracking the metric tons of electronic waste they collect, carefully separating out the percentage of valuable materials they can recover from it. They're measuring exactly how many tons of material are recycled, how much is composted, and how much is processed as waste to energy. The old cradle-to-grave model is being aggressively replaced by a cradle-to-cradle mindset. But that only works if the actual recycling infrastructure exists to support it.
Looking through the lens of the SASB standards, it becomes so clear that waste management is a deeply complex, highly scrutinized business, whether you're hauling trash from a suburban curb or incinerating industrial hazardous waste. Understanding these two distinct business structures leaves us with a really critical thought to end on today. As the circular economy continues to grow and the demand for raw material recovery skyrockets, will the massive, vertically integrated giants adapt their sprawling networks fast enough? Or will the highly focused, specialized resource recovery entities rule the future of waste? Thank you for watching this explainer.